Here we want to differentiate the function and then find a domain of the function where f of x is equal to x over 1 minus the natural log of x minus 1. So since we want to find the derivative, we want to find f prime of x. And in order to find f prime of x, what we want to do is we're going to use the quotient rule. So we're going to take the denominator, which is 1 minus the natural log of x minus 1, and then we're going to multiply it by the derivative of the numerator, which is 1, minus, we're going to take the numerator, which is x, and then we're going to multiply it by the derivative of the denominator. So the derivative of the denominator is we got minus natural log of x minus 1. So it's going to be minus 1 over x minus 1 times the derivative of what's inside, which is 1, all over 1 minus the natural log of x minus 1 squared. So let's go ahead and combine like terms in the numerator. So we have f prime of x, which is going to equal, we have 1 minus the natural log of x minus 1. And if we multiply negative x times negative 1 over x minus 1, we get plus x over x minus 1 divided by 1 minus the natural log of x minus 1 squared. Okay, so if we want to eliminate that fraction in the numerator, well, what we can do is we can multiply all the terms in the numerator by x minus 1, and we're also going to multiply the denominator by x minus 1. So therefore, if we distribute the x minus 1 to the first term, that means we have x minus 1 times 1 minus the natural log of x minus 1. Plus, we know this x minus 1 and that x minus 1 become 1, so it's plus x. And then we're going to divide that by x minus 1 times 1 minus the natural log of x minus 1 squared. So now we're going to distribute this x minus 1 to this one and then to the natural log of x minus 1. So we have f prime of x, which is going to equal x minus 1 minus parentheses x minus 1 times the natural log of x minus 1 plus x all over x minus 1 times 1 minus the natural log of x minus 1 squared. And so now we're almost done. We just now need to combine like terms. We can combine the x. So f prime of x is going to equal x plus x is 2x minus 1 minus parentheses x minus 1 times the natural log of x minus 1 divided by x minus 1 times 1 minus the natural log of x minus 1 squared. So therefore, there is the derivative of our function. Okay, so now what we want to do is we want to find the domain of our function. So if we want to find the domain of our function, so we need to take a look at the denominator. Okay, so what does the denominator tell us? Well, the denominator has the natural log of x minus 1. So the first thing is that when we take a look at the natural log of x minus 1, okay, this x minus 1 must be greater than 0. So when we solve for x, we know that x has to be greater than positive 1. Okay, and then also, if you take a look at the denominator here, we know if this is 1 minus, if this becomes 1, that becomes 1 minus 1, which is 0. So we cannot let this logarithm, which is the natural log of x minus 1, it cannot equal 1. So now what we can do is we can rewrite this in terms of an exponential form. Since we know that this is the base, we know that x minus 1 is going to equal e, which is the base, to the power of 1, which is this exponent here. So now, if we want to solve for x, we know that x is then equal to 1 plus e. Now remember, this cannot equal that. So therefore, now we can rewrite this domain. If we look at the number line, we know that it has to be greater than 1, and it cannot equal 1 plus e. So we know that it has to be greater than 1, and it goes to 1 plus e, and then 1 plus e to positive infinity. So therefore, the domain of our function goes from 1 to 1 plus e, union, and then 1 plus e to infinity. And therefore, there is the domain of our function.